Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 5.2, day 2, entitled Trigonometric Functions of Real Numbers. And today we're going to talk more about the values of certain trig functions, and then we're going to talk about fundamental identities as well. So, let's go slides. There we go. The nice thing about your graphing calculator is that it already has the trig values functioned and programmed into it. However, in this chapter, we have to be in radian mode. So you have to go to the mode button on your graphing calculator and scroll down and change it from degree into radian. So just arrow over so that the radian is blinking and then hit enter so that the little dark shadowy box is behind the radian so that the radian is highlighted. Okay? And then we can put sine and cosine and tangent right into our graphing calculator. To find the inverses, then you have to do 1 over sine, or 1 over cosine, or 1 over tangent. Or you could do sine divided by cosine, or cosine divided by sine. Okay? So when you're trying to find those inverses, you have to do some division. And that's what we just talked about. So let's try this out on your graphing calculator. You just want to type in sine of 2.2 for part A here. And this is just to make sure that you have your calculator set in the right mode and that you're able to type things in properly. Okay. And it says to round your results to 6 decimal places. So the sine of 2.2 should get you about 0.808496 if you're in the proper mode. And cosine of 1.1 should get you 0.453596. Okay. Now remember that yesterday we talked about sine being the y value in a terminal point and cosine being the x value in a terminal point. Okay, so remember that as well. The tangent of 28, I'm sorry, cotangent of 28. Now you can't type that directly into your calculator, so what you have to type in is 1 divided by the tangent of 28. Now when you do this on your calculator, you probably want to put the tangent of 28 in parentheses. And you should get negative 3.553236. And then cosecant, again, we can't put that directly into our calculator. I don't have a cosecant button, so we have to do 1 over sine of 0.98. And again, put that sine in parentheses. And then you'll get 1.204098 if you've typed that in properly. So this is just to get you familiar with putting values into your calculator, making sure it's in the right mode. Eventually we'll get to a point where you have to know what mode you need to be in, so there will be some switching back and forth between degree and radian mode. Okay, but for now we're going to be using radian mode. Now we're going to talk about some other characteristics, I guess, of these trig functions. And there's a way to remember when trig functions are positive and negative as you work your way around the unit circle. Now, if we take the sine of a negative t value, so if we're in the fourth quadrant, your sine value is going to be negative. If we do the cosine of that same negative t value, your x value is going to be positive. And then tangent would be sine over cosine, so that's also going to be negative. So really the only thing that's positive in that fourth quadrant is going to be the cosine values. Okay, and we saw yesterday that in the first quadrant everything is positive. So there's a little mnemonic device to help you remember which ones are positive in which quadrant. And that is all students take calculus. So in the first quadrant, all of them are positive. In the second quadrant, only the signs are positive. In the third quadrant, tangent is positive, and in the fourth quadrant, cosine is positive. Okay, so they're going to refer to these as even and odd functions. Okay, sine and tangent are going to be odd, meaning that they keep their negatives. So when you take sine of a negative, it makes your answer negative, or the tangent of a negative, it makes your answer negative. Cosine is going to be even because when you take the cosine of a negative value, you get a positive value out. So they have this chart in your book that summarizes all that information. Okay, basically the cosine and the secant are going to be ones that switch from a negative to a positive. So if you're taking the cosine or the secant of a negative t value, it's going to switch to a positive t value in your answer. Okay, that's because in that fourth quadrant, cosine and then its inverse are going to be positive. So you can use this information to evaluate problems in a couple different ways. If you want to remember where certain t values are going to be positive and negative, if you want to memorize that little chart, you can. If you want to draw a little picture and write all students take calculus, that's fine too. So there's several different ways to approach this and still get the correct answer. But if we're using that even and oddness that we were talking about in that little box, okay, sine of a negative t value is going to give you a negative answer. So really this is going to be the same as negative sine of pi over 6. Okay, so pi over 6, we have to remember where that is on our unit circle. Okay, pi over 6 is going to be right here. It's that first 30-degree section. The terminal point is going to be square root 3 over 2, 1/2. And remember the ordered pairs are cosine sine. So my answer for the sine of pi over 6 would be 1/2, but I have this negative out front. So this will be negative 1/2. You can think of it like we did previously, where you went down pi over 6 and knew that you were in the fourth quadrant. You knew your reference angle was pi over 6, so you knew you're going to have this same ordered pair for your terminal point, but in the fourth quadrant, everything's positive and then negative, so that's why the 1/2 is negative, and that's why your answer is negative. So you can think through this using the information that we've talked about already in previous sections of notes, or you can apply this new even oddness on the previous slide in that little box. Okay, cosine of a negative value though, if you're using the even and oddness, remember that's just going to be the same as cosine of pi over 4. Cosine and then its inverse, those are the ones that stay positive. Okay, so that then is just going to be square root 2 over 2. So all the fourths, remember, have the square root 2 over 2's. Now again, if you want to draw a little picture, you can. If you want to go down pi over 4, you know it's right here. You know the reference angle is going to be a positive pi over 4. And the terminal points, square root 2 over 2, square root 2 over 2. But you're in the fourth quadrant, so everything's positive and then negative. And the cosine is the x value, so it's going to be positive and then negative for the y value, so you want the positive square root 2 over 2 for your answer. Okay, so that's two ways that you can think through this problem and get to the correct value at the end, whichever path you decide to take. Whichever way makes more sense to you, that's how you need to think of it. I think sometimes knowing all those little charts and all the positives and negatives and evens and odds, I think sometimes that can be a little more brain power, take more brain power to remember all those little details than just remembering where you're located at in the unit circle and using your reference angles. Okay. All right, last thing we're going to talk about then is some of these fundamental identities. And the trigonometric functions are all related to each other, and so they're called trigonometric identities. Okay? And we've already been working a lot with the reciprocal identities. We know that Cosecant is the inverse of sine, and secant is the inverse of cosine, and cotangent is the inverse of tangent. We know those. And we also know tangent is sine over cosine, and cotangent is cosine over sine. So we know those already. These new ones, though, these Pythagorean identities, these we haven't seen a lot yet. You probably didn't see them much in Algebra 2. You might have seen this first one, the Pythagorean identity here, okay? But I'm going to show you where that comes from and where these other two come from as well. Okay. Remember, we know a few facts now. We know that x is equal to the cosine values in the terminal points, and the y value is the sine, okay, or sine is the y value in the terminal point, and cosine is the x value in the terminal point. And then we also have an equation for a circle, x squared plus y squared equals 1. Since we're dealing with a unit circle, we've been using that equation. Okay, we used it on the very first day of this chapter. So if I take x squared, which is cosine, and then I take, whoops, I need my t value in there. Squeeze a t in there. And then my y value is sine, so sine squared equals 1. That's my first Pythagorean identity. That was what was on the other slide. They just wrote it sine squared plus cosine squared equals 1. Okay, instead of cosine plus sine. Now remember that it's the trig function that gets squared, not the t value. The t is just your distance. Okay. And then if we take that statement, I'll write it the way the chart wrote it. Sine squared and cosine squared equals 1. If we take that and we divide everything by cosine, then we get the second trig identity there. Now, sine over cosine, remember that's tangent, and cosine over cosine, that's just 1. And then 1 over cosine, that's secant. So that's our second trig identity, or Pythagorean identity, I guess is what they call it, the Pythagorean identity. And then if I go back to that same Pythagorean identity, that very first one, sine squared plus cosine squared equals 1. If I take that and I divide everything by sine, then I get 1. And cosine over sine, that's cotangent. And then 1 over sine, that's cosecant. And that is my third Pythagorean identity. So these are identities, these are equations that we can use to help us solve for any trig function that we don't already know. So if we know the sine and the cosine, or if we know sine, we can find cosine. Or if we know tangent, we can find secant. If we know cotangent, we could find cosecant. Okay? So if you only know one of the 6 trig identities, or 6 trig functions, then you could use our knowledge of the unit circle, or you could use these 3 Pythagorean identities to help you find the other 5. And that's what we're going to do. Okay? Okay. So again, if we know the value of any one of the trig functions, then we can find the values for the others. All right, so that's what we're going to do in our last example here, example 5. They tell us that cosine of t is 3 over 5, and t is in the 4th quadrant. So find the other trig values. Okay, now there's a couple different ways that we could do this. We could do this geometrically, or we could do it algebraically. Okay, so geometrically, let me kind of divide this up here. I'll do the geometric way first. This way I think is a little bit easier to think of sometimes, but it's based on a triangle, basically. Okay. Let's just put t here. Now, we know that cosine of t is 3 over 5, and cosine is going to be adjacent over hypotenuse. So my adjacent side is 3, my hypotenuse is 5. Now, if this is a right triangle, and if you know your Pythagorean identities, or your triples, I'm sorry, your Pythagorean triples, 3, 4, 5 is a Pythagorean triple, or you'd have to do Pythagorean theorem to find 4. Okay, you'd have to do 3 squared plus something squared equals 5 squared. Okay, and then 25 minus 9 is 16. Square root of that is 4. Okay, so once you know that, then you can basically do your ratios to find the rest of your values. Okay, so sine of t, sine would be opposite over hypotenuse, so that's 4 over 5. They told us cosine. And then tangent is going to be opposite over adjacent, so that's 4 over 3. And then we have our inverses. We have cosecant, and then we have secant, which is the inverse of cosine, so that's 5 over 3. And then we have cotangent, which is 3 over 4. Now, the only other thing that I need to really make these answers 100% correct is to know that I'm in quadrant 4. And in quadrant 4, you have to be positive and then negative. Okay? If you want to think of that all students take calculus thing, all students take calculus. Remember, cosine is going to be the one that's positive in the fourth quadrant. So cosine and its inverse, secant, are going to be positive. The rest are going to be negative. So sine is negative, tangent's negative, and then the inverse of sine and the inverse of tangent, they're negative. Okay? So that's one way that you can work through this. The other way then is to think of it algebraically with those Pythagorean identities that we just talked about. Okay, they tell you the cosine, and if we go back a slide here, okay, they tell us cosine, so then I can use this identity right here to find sine. So if I start off with sine squared and cosine squared equals 1, my cosine value was 3/5. So I have to square that. So it's kind of funky with the way it's written and the way you substitute in. Okay, they gave us a t value of 3/5, but we have to square it because it's cosine squared. Okay, so then you've got sine squared t. So this is 9 over 25. And then I would subtract the 9 over 25, so I get sine squared t. So think of 1 as like 25 over 25 minus 9. That's going to be 16 out of 25. And then I've got to take the square root of both sides. So I'll get the sine, let me write it over here. Sine of t is going to be 4 over 5. Okay, now remember I'm in quadrant 4, and sine is negative in the fourth quadrant, so I've got to make it negative. Okay, and then again, they told me cosine is 3/5, so I knew that already. And then tangent, tangent of t. Tangent would be sine over cosine, so negative 4/5 over 3/5. Then I'd have to multiply by the reciprocal. I'd have to multiply by 5 over 3. So that would be negative 4 over 3. So those are the same values that I got over here. Negative 4/5, 3/5, and negative 4/3. And then I do my inverses. My cosecant, I'm just going to take the reciprocal of this, negative 5 over 4. My secant, take the reciprocal of that, 5/3. And then my cotangent, and take the reciprocal here, negative 3/4. Okay, so there's two ways that you could work through this problem. You can think of it geometrically, you can think of it algebraically. Both are completely correct. Okay, so this is going to be your homework to practice these concepts this evening. And remember, I have all the solutions worked out in the binder in the classroom. All these problems are odd, so check your answers in the back of the book. And if you have any questions, come on in and see me before school.